All right, let's get right after this. SAT, this is practice number 9. So official SAT number 9. And this is the no calculator part. There should be a link below where you can go on there and click and actually take the test and get it graded, see which ones you missed, so you can kind of skip through the video to the problems that you missed and that you need some help on. So let's get after it. All right, number 1. Starts off with the systems of equations. It says for the system of equations above, what is the value of x plus y? So it looks like I'm going to have to solve. Sometimes I can just add or subtract these two rows and it'll turn into x plus y. I don't really see that happening here because when I add them I get 3x plus y. So sometimes you get lucky and that's what they want. So I always look for that first, but looks like I'm not going to get that lucky. So let's just go after one of the letters. If I multiply this top row by 2, I'm going to eliminate y's when I add them up. So the top row will be 4x minus 2y equals 16. And the bottom row, I'm going to leave the same. X plus 2y equals 4. Why I multiplied by 2 is because I wanted to get opposites. I got a negative 2y and a positive 2y. And when I add those, they'll cancel. So I'm going to add them up. I'll get 5x equals 20, which hooks me up and gives me x equals 4. Now that's not the answer, so they probably want you to pick B, but don't pick that because we now need to substitute it back in to get y. So I'm going to take this 4 and plug it in either equation. I'll probably plug it in the bottom one. So when I plug it in the bottom one, I get 4 plus 2 times y equals 4. Subtract 4 from both sides, 2y equals 0. Divide by 2, divide by 2. So it looks like y equals 0. So in this case, when I add x plus y, 4 plus 0, it does come out to be 4. So even if we would have did it wrong, we would have got lucky on this one. Moving forward, number 2. It says which of the following is equivalent to this expression? So probably the easiest way here is just to distribute combine like terms. So I'm going to get 2x squared minus 2x. Here I'm going to get a positive 3x squared and a negative 3x. And then I gather my like terms, so these x squareds can be combined to be 5. And then these x terms, negative 2, negative 3, are going to be negative 5. So that matches up with A. All right, moving right along to number 3. Which of the following statements is true about the graph of that equation in the xy plane? Well, I kind of peek at the answers, and it's asking me about slope and about y-intercept. So those are the key features that I need to pull from that equation. Unfortunately, it's in standard form. So I have 2y minus 3x equals negative 4. I would put it in slope-intercept form. Y equals mx plus b, because then it's easy to know that the number in front of the x is the slope, and the back number, the constant, is the y-intercept. So let's just rewrite this. I'm going to take away, actually, I'm not going to mess with the y just yet. I'm going to add the 3x to the other side. So I have 2y, that canceled. And I'm going to put the 3x in front and the minus 4 in the back, just so it kind of matches this format. Now I'm going to divide everybody by 2 because I want y. So I get y equals 3/2 x minus 2. So it looks like my slope is positive. So my slope is positive, and my y-intercept is negative. So positive slope, negative y-intercept. So it looks like the correct answer here is D. All right, keep on going. Scroll down to number 4. So it looks like we have a story problem. This is one that they call constructing a linear model because they give us a story and we have to basically build a model that represents it. So the front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. So I'm just going to kind of sketch this really fast. So there's the ground, and we have some sort of roller coaster car that I'm assuming is going to head up. So we got our car here, and we're 15 feet above the ground. And if the front of the roller coaster car rises at a constant rate of 8 feet every second, so let's say this is 0 seconds. And I probably should have put this in a straight line as opposed to kind of on a curvy track. But we're going to go straight up, and it looks like we're going to go up 8 feet for every 1 second over. So we have a slope of 8 over 1. So that rate of change, that vertical change over horizontal change, tells me I have a slope of 8. So looking at these equations, this is a slope of 15. This is a slope of 15. So I got it down to A or C. And then my y-intercept is this back number. And right here is what we want because we started 15 feet above the ground. You know, if you kind of thought about making a little table where you had seconds and you had height, if you kind of thought about a table format, at time 0, we're at 15 feet above the ground. Well, then 1 second later, we rose another 8 feet. You know, 2 seconds later, another 8 feet. So I can kind of see right there, that's my y-intercept. Number 5, this is the opposite of what we just did. This is interpreting a linear model. We don't have to construct it, but we have to interpret it. They give me the model. I just got to use it. Equation above gives the amount of cost in dollars. So this is our money. An electrician charges for a job. The job takes 8 hours. Sanchez and Roland each hired the electrician. The electrician worked 2 hours longer for Sanchez than Roland. So let's kind of jot this down. So if we have Sanchez and we have Roland, and the Sanchez job was 2 hours longer. So he's going to pay more. How much more did the electrician charge? Well, the 125 doesn't have anything to do with time. So that must just be the cost of him coming to the house and showing up. But it looks like I can interpret this. This is $75 per hour. All right. So if Sanchez's job is 2 hours longer, it's going to be 2 times 75. It's going to be $150 more dollars. If you made a mistake and you chose D, you found the total price of a job with 2 hours, but that wouldn't be right in this case. Number 6 over here, we get into a circle. And so let's see what they're asking. So a circle above has center 0, the length of arc A through D to C. So we're talking about this arc right here. Has a length of 5 pi. So 5 times 3.14. And x is 100. So 100 degrees. You know, the size of the arc kind of is related to, or the size of that angle is related to the arc size. And it says, so what is the length of arc ABC? So they want me to figure out this other side. So I think I'm going to set up a proportion. And I'm going to kind of say, hey, if 100 degrees gives me an arc of 5 pi, well, what would the full circle be? Or I could even just say, you know, a full circle is 360. So I know that this red side over here is 260 degrees. So if 100 degrees gives me 5 pi, 260 degrees gives me how many pi? So I'm going to do a little cross multiplying. I got 100x. Very common skill on the SAT is cross multiplying proportions. 5 times 260 is 1,300 pi. And divide this side by 100. Divide this side by 100, which basically wipes out the zeros. So it looks like it's going to be 13 pi. So the correct answer there would be B. Number 7 looks like a pretty standard proportion. So I think we can just set it up. I always think it's helpful that if you have a fraction on one side and a whole number on the other, to put a 1 under the whole number. So 8 over x equals 160. I like to put a 1 under it because now it's very clear what to do. I got 8 equals 160x. Divide by 160, divide by 160. I don't even need to touch a calculator because 8 divided by 160 is a very small number. So that wipes out all of these. Correct answer is D. So that's probably why it's on the no calculator section. Moving right along. The equation above, A is a number, a constant. If no value satisfies the equation, what is the value of A? Well, that's an important clue because if no value satisfies it, means there's no solution, you're wanting to get something like this. Like if you get x's on both sides and then you get some number, like let's say 1, that's impossible to solve because one side will always be bigger than the other. So whenever you want to have no solution, you want the exact same amount of x's, but different constants. So let's kind of see what we got here. On the left, I have 2ax minus 15. On the right, let me simplify this by distributing 3x plus 15 plus 5x minus 5. I'm going to do a little bit of cleaning up over there on that side. Some like terms, 3x and 5x, that's 8x. And then I have 15 and negative 5, that's plus 10. And then if I put this 15 over here, we're going to have 2ax equals 8x plus 25. Well, again, to kind of create this situation, I need this to match that because then I'm going to have the same amount of x's on each side. I'll have 8x on one side, 8x on the other, but then I'll have that constant that screws it up. So basically, I got to figure out when is 2a equal to 8. And when you divide, you get a equals 4. So algebra isn't crazy, it's just kind of worded weird. And if you weren't sure about one or no solution, that would be a bit of a challenge. This problem looks tough, but it's really not too bad. It says you have a system of 3 equations. So that's not very common. You know, normally you have a system of 2 equations, 2 lines. But this time we have 3. And it says, how many solutions does this system have? So if you solve the entire system, that means you got to work for all 3. Well, there's only one ordered pair up here that works for all 3. And that's that dot right there. You know, because that dot is on this curve. That dot is on this line, and that dot is on this line. So that red dot is the only point, it's the only XY combination that made everybody work. So there's one solution to this system. All right, moving on to number 10. Let's be up here at the top. So what do we got here? This one says the equation above is true for all x, where a and b are numbers, constants. What's the value of a times b? So I don't really quite know where they're going to go with this, but usually I just start kind of doing my algebra rules and something kind of comes out. So let's multiply this out. We're going to distribute the ax to all these pieces. So I'm going to get ax times 5x squared. Well, that's 5a x to the third. Ax times negative bx, well, that's negative abx squared. Ax times the 4 is plus 4ax. Now I got to do the 3 times all these pieces. So I'm going to kind of draw these arrows underneath. 3 times 5x squared, well, that's 15x squared. So kind of, I guess, put that right here. I'm going to run out of room. 15x squared. I get a negative 3bx. And then I get a positive 12. Now, all of that stuff there, I'm trying to kind of match up with the other side. So I'm trying to get all that stuff to kind of add up right. And let's kind of see what we can do. I'm going to kind of move over so I got more room here. So let me come way over here. Actually, I might be able to just do this and save a little bit of time. I'm going to just put equals I'm going to put this other piece over here. So 20x to the third minus 9x squared minus 2x plus 12. So I want to get both sides to match each other. So the first thing that I notice is to get this 20x cubed to match this 5ax cubed, I need to get 20 to equal 5a. And it looks like a is going to be 4, which is kind of weird because that last problem a was 4. So now that I know a is 4, I'm going to plug that in, and I'm going to get 20x cubed minus, I now know a is 4, 4bx squared, plus, if a is 4, 4 times 4, that's 16x, plus 15x squared minus 36x plus 12. Well, let's kind of clean up a little bit of this stuff here. So where else has a b term in it that we need to match? So I have a 15x squared term on this side that I want to get rid of and put it over here to figure out really how many x squareds I need. So it looks like that's negative 24x squared. So this piece is kind of gone now. And that's going to help me get b, because it looks like I need to get negative 4bx squared to equal negative 24x squared. So let's see what we can do to get that to match up. It looks like b is going to have to be 6. Yeah, because if I go negative 4 times 6, that's going to give me negative 24x squared. So b is 6, a is 4. So, and they want to know what is a times b. Well, 6 times 4 gives me an answer of 24. So the correct answer there comes out to be C. All right. Moving right along. That problem was a little tricky. Number 11, another proportion. So we need to do some cross multiplying here. I do see that there's multiple. There's some of these with several right answers, so that's going to be a little bit of a challenge. Well, let's just cross multiply. Anytime I see a proportion, that's my move. 2x times x is 2x squared. 2x times the negative 3 is negative 6x. So we have a quadratic. We have an x squared in there. So the rule is pretty much always set one side equal to 0. So I'm going to minus that 2x from both sides. So I'll get 0 equals 2x squared minus 8x. And I think I'm going to have to factor a greatest common factor out. So the biggest thing I can pull out of these two terms, I can pull a 2 out, and I can also pull an x out. It's kind of like a reverse distributive property. So 2x times x is 2x squared. This is going to be a negative 4. And now I use what's the zero product property, because something times something equals 0. So either you're 0 or you're going to be 0. So if either one of those parentheses is 0, that gives me a total answer of 0. So 4 and 0 are the correct answers. Looks like we got B there. Number 12, which of the following is equivalent to the expression above when x is greater than 0? So there's two ways typically to solve these problems. There's like the hardcore algebra way, and then there is a, hey, pick a number and stick it in kind of way. If you're not very good at algebra, I would pick a small number and plug it in and see what you get. So for instance, I'm going to just quickly go this route. Let's say that I just arbitrarily say x equals 3. Well, when I plug that in, that gives me 1 over 2 times 3 is 6 plus 1. That gives me 1/7 plus 5. So 5 and a 7th. So that means when you stick 3 in, you should get an answer of a little over 5. So if I do that and I start plugging it in here, if I put 3 in, 2 times 3 is 6 plus 5, that's 11. 2 times 3 is 6 plus 1, well, that's 7. 11 divided by 7 isn't 5 point something. So you're out. If I try it again, 2 times 3 is 6. 6 plus 6 is 12. 12 divided by 7 is not 5 point something. 10 times 3 is 30. 30 plus 5, that's 35. 2 times 3 is 6 plus 1, that's 7. That's exactly 5, so it's close, but it's not it. Let's try this one. 10 times 3 is 30, plus 6 is 36. 2 times 3 plus 1 is 7, and that does go in there 5 times with 1 left over. So the correct answer is D. Might not have been the cleanest way, but if you suck at algebra, that's something you can do. Whenever they say is something equivalent to something, you can always stick a number in and get them to match up. Here's the hardcore traditional way. If you're going to add a fraction to another number, you need a common denominator. So we have this fraction. If I want to add that to 5, I need to get 5 over 2x plus 1, because then they'll have like bottom numbers. But if I multiply the bottom by 2x plus 1, I got to do the top times 2x plus 1. Because really, I just multiplied 5 by 1. I didn't hurt it. But now I have some bottom numbers that match. So when you add fractions, think about like if you add like 1/5 plus 2/5. The rule when you add fractions are if the bottom numbers are the same, keep it the same and add the top. So I'm going to keep my bottom the same, but now I got to add the top, which is going to be 1 plus, and then I got to distribute here, 10x plus 5. So that's actually 10x plus 6 when I put these two together. And that gets me the same answer. So I don't know which way is faster. I guess it depends on if the answer was A or D. If the answer would have been A, it would have been much quicker to jam that 3 in. All right, number 13. What do we got going here? The graph of the function in the xy plane above is a parabola. Which of the following defines f? So couple different ways you can do this one. If you're good with transformations, you could use that kind of power. And basically the rule is, if you just do the parent function, y equals x squared, it's a parabola that cuts right through the vertex at 0, 0. Now, when you add a number to the end of this, like let's say I add a 2 there, it just moves it up 2 units. All right? It's a shift up, that constant at the end. If you want to move it left to right, you got to put numbers in parentheses. So for instance, if I had like y equals, x minus 2 squared plus 4, the number inside parentheses, you got to kind of be careful here. It's kind of the opposite of what you think. If that's a minus 2, it actually is going to shift the graph to right 2, which is not intuitive. The plus 4 is going to shift it up. So the back number does what it's supposed to do. Positive is up, negative is down. The number in parentheses, if it's right 2, that was negative. If it was positive, we would have went left 2. So that's just kind of some rules of transformations, which could help on this problem. Because I see on this problem, the vertex moved 3 to the right and 1 up. So I know in my parentheses, 3 to the right is that, and 1 up is this. Well, that kind of wipes out these two. And now we're kind of in a dogfight between A and C. One has this constant in front. And what that does, a number in front that's greater than 1, like makes it really skinny. So a normal parabola would go over 1, up 1, over 1, up 1, and then over 2, up 4. This guy doesn't, man. He goes over 1 and jumps way up 4. So I know the answer is A because it got stretched. It's a skinny parabola. It got stretched by a factor of 4. A way I show some of my kids who are struggling with algebra and they don't remember the transformation rules, you get on the SAT and you're like, oh crap, I forgot that stuff. Pick a point, but not the vertex. So simply choose a point, but not the vertex. Because the vertex is going to be the same for both of these. It's just going to be fatter or skinnier. So pick a point like 2, 5 and plug it in and see if it works. If you live on the line, you got to work. So if I plug that in, 4 times 2 take away 3 squared plus 1, does that equal, remember f of x is just y, does that equal 5? And it better if we got the right answer. So 2 minus 3 is negative 1. Times it by itself is positive 1. Times by 4 is 4. Hold on here. I plugged that in right. Yeah, 4 plus 1 is, so this is 1. 4 plus 1 is 4. I don't know why I put a plus 5 at the back. The original equation had a 1 there. So 4 plus 1, it does check out. It comes out to be 5, so we know it's A. If you would have tried to put it in this other one, you'd have 2 take away 3 squared plus 1, which is really 1 plus 1, which would have come out to be 2, and we needed it to be a 5. So that's how I also knew this was eliminated. All right, inequality. Shaded regions. I'm going to give you a shortcut. One method is you could choose a test point, see if it works. I'm not really a big fan of that method. I'm kind of a fan of this method. So you see this greater than symbol? Y is greater than x plus 2. If you see y is greater than, you need to shade above that line. Okay? So the very first part, y equals x plus 2. Well, that line has a slope of 1 because that's the number in front of the x. You don't really see it. And has a y-intercept of 2. So let's look on the graph. Who's got a slope of 1, y-intercept of 2? So that's this line, and that's this line, and that's this line, and that's this line. Well, if it's y is greater than, we need the shade to be above the line. So that wipes out A, because this shade is below the line. So that wipes him out. B is okay, because that's above the blue line. C is okay, because that's above the blue line. D is not, because it's below. So I've got it down to a 50-50. Now this one's a little trickier, because I can't just look at the less than and think it's below. I actually got to get it into slope-intercept form. So let me just quickly get it into slope-intercept form. I'm going to move the x to the other side. And I'm going to divide by 3, which in this case, since we're dividing by a positive number, we do not flip the sign. So really what happens now doesn't even matter. But I know we're going to be less than the other line. So we're going to be below, and these lines got to be that line. They have a slope of negative 2/3. They cross at 2. But I need to be below the red line. So I think this situation here is where the shaded area is below the red, it's above the blue, and that's the solution. So the correct answer there is B. Some people teach a different method, and they pick a test point in every region. So if they want to try this one, they plug 0, 0 in. And they see if it's true in both equations. Well, right away, 0 is not greater than or equal to 2. So I know you're out. And then if I go to B, I test a point, and I got to pick one somewhere. So maybe I pick like, this point. Maybe I pick x is -3, y is 1. Well, then I got to plug it into here, plug it into here. If it works for both, I'm good to go. That can be very time consuming, so I think the shade above, shade below is a little bit faster method when you get into these type of problems on a time test. Number 15, this one has tripped me up before, so be careful. And I don't like this question because I think the SAT is kind of petty. So here's what the SAT says. They said that if they ever give you a problem like, hey, what's the square root of 4? They want the answer to only be 2. They don't believe that -2 is also an answer. So they're just kind of using what's called the principal root. And I think it's kind of crappy. But that's how they kind of got me on this one. So when you work this problem out and you plug some numbers in, well, I think the easiest way is just to plug it in. This is x, this is y. Or no, that's not x and y. What am I saying? Those are two x values. Let's plug it in and see if it's true. So if I stick -1 in here, and I stick -1 in there, I get the square root of -1 plus 2 equals a minus -1. Well, that comes out to be the square root of 1 equals 1. And that's true. So I know -1 works. So let me try to put 2 in here. If I try to put 2 in here, I get the square root of 2 plus 2 equals -2. And sometimes when you solve equations and you take the square root of a number, we say that there's two answers, the positive and the negative. So I could very easily see why somebody chose A, but they don't agree with that. So the correct answer on their test is B. I don't really like that. I'm not a fan of how they word these problems and kind of their rules, because I squared both sides, which is kind of the traditional way. And I got x plus 2 equals x squared. Negative x times negative x is x squared. I set it equal to 0. And then I factored it. I found two numbers that times together to make -1 and add together, if you remember that from algebra. So I knew that x plus 1 times x minus 2 would give me that trinomial. And then I used that zero product property we used earlier in the test to find out this parenthesis 0 at -1, this one 0 at 2. So I chose A, but then when I read their answers, it was B, and it was kind of from that loophole. So be careful on that. Just know that they only want the principal root, which to me is kind of crappy, but whatever. I don't get to write the SAT, I guess. So number 16, what is the volume of a right rectangular prism? Height, width, length. If you forgot your formulas, you can go all the way back to the beginning, right here. And a right rectangular prism is right here. So volume is just length times width times height. So that makes this problem super easy. All I have to do is multiply all those numbers together, which is right here. So let's get after it. The volume of a prism is length times width times height, which is 360. Also be aware that every single problem on the free response, there are no negative answers. There's no negative to bubble in, so be careful on those. If x satisfies the equation above, what is the value of 2x plus 1? So this is like a solve-resolve. Be really careful. We need to solve this equation first. Let's go -2 minus 2. So 4x equals 2. And then divide by 4, divide by 4. I get x equals 1/2, okay, or 0.5. A lot of kids put that answer because they forget the second part, which is, hey, now you know the answer. What is 2x plus 1? So you want to jam it in over here. 2 times 1/2 or 2 times 0.5 plus 1. Well, 2 times 1/2 is 1. 1 plus 1 is 2. So the final answer is 2. Be really careful on those solve-resolves. All right, number 18. This is a function graph. They always put these on here, usually on the no calculator. So it says, the figure above shows the graph of f. And just how you interpret this graph. So let me kind of quickly draw in to I want to really darken in the axes because these are kind of hard for me to see. And then they had some dots on here, that dot, that dot, that dot, that dot, that dot. Well, how you interpret those is, for instance, like this dot right here. That dot says that in the f function, the input is what's in parentheses. So when you input x, which in this case is at -3, so when x is -3, the y value is 2, because that's where that order pair lives. So this is x, this is y. Always put the x in the parentheses, and then the height is going to be your y value. So it says that's the f function. Well, then it says the g function, which is not shown, it's the same as the f function, but there's just a +6 at the back. So that basically says we need to move this function up 6 units. So the g function is basically going to go 1, 2, 3, 4, 5, 6. And it's going to be an exact mirror. It's going to be a mirror of him. So this point's going to get moved up 6. This one's up 6. So we're going to kind of go like, bounce down, bounce up, bounce down, bounce up. Kind of doing that thing. So what is the maximum value of g? Well, the maximum value of f was right here. It was at a height of 2. So if we go 6 up, the maximum height of g is going to be 8. So kind of a weirdly worded question, but not horrible. Number 19, triangle PQR has a right angle of Q. So let's draw that. So PQR, right angle of Q. So I'm just going to kind of stick P and R on there. And it says the sine of R is 4 over 5. So hopefully you remember SOHCAHTOA, which is a mnemonic device to remember sine, cos, tan. So the sine is opposite. It's the O on top of H, which represents the hypotenuse. Cosine would be adjacent over hypotenuse, and tangent is opposite over adjacent. And if you haven't had this in geometry or advanced algebra or trig, this is going to kind of lose you a little bit, but do your best. So the sine of R, so R is my reference angle. That's where my dude's standing. So I'm going to put a dude down here at R. That's the position, that's the reference angle. So if we label the triangle, the hypotenuse is always across from the 90. So the hypotenuse is here. The opposite leg is straight across from me. So this guy right across from me, he's called the opposite leg. And then the leg that's closest to me is the adjacent leg. So they give me a clue, man. They said, hey, the sine of R is 4 over 5. So I know that this opposite leg is 4. And I know this hypotenuse, this H, is 5. So then it says, what is the value of the tangent of P? So they switch gears on me. They're like, hey, what's tangent of P? So now the game changes. The game changes, and now my guy is standing at P, and tangent is opposite over adjacent. Well, according to P, opposite is down here. So you're the opposite, and you are now the adjacent. So I got part of my answer right now. The tangent of P is opposite over adjacent. I know the opposite is 4, or the adjacent's 4, but I don't know this opposite down here. I'm not quite sure what that is. So you could do a couple things. If you know some Pythagorean triples, you will know that 3, 4, 5 is a very common Pythagorean triple. So that's how I know that this answer is going to be 3. But if you didn't know it, you could call this x, and you could just do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. X squared plus 16 is 25. Minus 16, x squared equals 9. Square root. And you'd eventually get that 3 down here on the bottom. But knowing this triple is very helpful. It'll save you a lot of time. So the final answer, the tangent of P, is the ratio 3 over 4. They probably would also accept 0.75, but why do that if you don't need to? Last one here, number 20. It's like we have a graph. The graph of a linear function is shown above. The graph of g is not shown, so same kind of like what they did to us earlier. G is perpendicular to f. That's the huge clue on this one. So I'm going to kind of come over here. G is perpendicular to f. Perpendicular means you're 90 degrees to each other. Well, whenever they talk about perpendicular or parallel on the SAT, you need to think about slope. If you are perpendicular, slopes of perpendicular lines have to be what's called opposite reciprocals. And I'll explain that in a minute. But you got to do two things. You got to be opposite reciprocals. So if we look at this line right here, this F line, his slope is down 2 over 1. All right? So we're dropping 2. Kind of come back here to this guy. We're dropping 2, and we're running 1. So if you drop 2 and run 1, that means that F has a slope of negative 2 over 1. Down 2, right 1. Well, if I want to be G, I need to be the opposite of that. So instead of being negative slope, I need a positive slope. And a reciprocal just means you're going to flip the fraction. So G needs to be a positive 1/2 slope, which means we're going to go up 1, right 2. And it says G is perpendicular, so I got a slope, and it goes through the point 1, 3. So if you go through the point 1, 3, and you have a slope of up 1 over 2, and if I kind of run it, I can go down 1 the other way too. So there's where it cuts through. So what do we want to know? What is the value of G of 0? So that means when x is 0, what does y equal? Well, at x equals 0, it looks like it's cut right through the middle there. So the correct answer, 2.5. That's a tough question. Number 20 is always going to be a tough question.